All right, so we're gonna start breathing. So first things first, I want to do the division of the respiratory system. So we have the lungs, and from the lungs we've got bronchioles, and then we have alveoli. And the alveoli are very important because this is where we're going to have the gas exchange. They have a very large surface area. Okay, so essentially the way we breathe is called negative breathing. And this takes Boyle's law into account. Essentially what it says is the diaphragm contracting will increase the volume, which decreases pressure. And O2 will go from O2 high to O2 low. And these actually shouldn't be concentration, these should be pressures. Boyle's law says there's a, let me put this right here for you. Over volume. So it's an inverse relationship. And exhaling is basically, this is inhale. Exhale is an increase in pressure, which pushes the air out because it's going to go from high pressure to low pressure. And it's going to do the same thing. So the respiratory system and the circulatory system are interconnected. So here's basically how it's going to work. Deoxygenated blood will come in through the arteries. And arteries are away from heart. And then you are going to have the pulmonary vein. And what this is going to do is this is going to take oxygenated blood back to the heart. And that blood will eventually be dispersed to the rest of the body. So the general pathway that this works is going to be the right ventricle, which is deoxygenated blood, will go to the alveoli. And then you're going to have this will go to the left atrium where you're going to have oxygenated blood. And then the left atrium will be pumped using the aorta. All that blood, this oxygenated blood, will be dispersed to the rest of the body, being pumped through the aorta. So, in addition to, oops. Let me just lasso this right here. So the body's also involved with thermoregulation. More blood equals more Fahrenheit. So you got more temperature in the body. The immune cells are in the lungs as well. So you've got mast cells, which will be involved in immune responses. And lungs also have IgA antibodies. There are also macrophages in the immune system. Something that I want to know on the side. Um, you have certain bacteria that will be inside alveolar macrophage. I think from what I can remember, you've got Listeria monocytogenes that could do that. Um, and lastly, we've got uh, pH regulation. So what this is going to do is actually it's going to have CO2 plus H2O yields bicarbonate, which will be H plus. And this follows Le Chatelier's principle. So let's say, for example, the pH increases. If the pH increases, your concentration of H plus decreases. And if that's the case, then CO2 will be used up in order to build more of the H plus ions. On the other hand, if you don't have enough CO2 in your body, your equilibrium will shift to the left, and your pH will increase because your concentration of H plus will decrease. See, there's probably one last thing I can write for that, and that is slow respiration equals more CO2, which is trapped, which is more H plus. This makes sense because you have an increase of a CO2 will drive the reaction to the right. However, when you have lots of respiration, meaning you're breathing really fast, CO2 is expelled out of the body, and when that's done, your H plus is used up and drives this reaction left in order to compensate for the used up CO2.